Common set operations are union of sets, intersection of sets, set subtraction or difference of sets, and complements of sets. Let's walk through an example of all four with the following three sets. First, set A, which contains the elements 1, 2, 3, 4, 5. Set B, which contains the elements 2, 4, 6, 8, 10. And set U, which contains the integers 1 through 10. For the first three of these operations, we will be focusing on just sets A and B. U, which we call the universal set, will be used when talking about complements. Also, it's important to note that the result of all these operations is a set. So let's start with the union of sets. The union of set A and set B, denoted here, well, the result of this operation is the set containing all of the elements from both sets A and set B's in the same set. So all of the elements from set A will be in the set, as well as all the elements from set B. When an element is contained in both sets, we do not repeat it in this final result, since each element can only appear once within a set. So essentially, unions just merge all the elements together, almost like a stew or a soup. Next, let's talk about the intersection of set A and set B, denoted here. The result of this operation is a set containing all the elements that are in both set A and set B. So when looking at set A and set B, what elements are contained in both sets? Well, set B only contains even numbers. Do the even numbers in set A also appear in set B? Yes. The elements 2 and 4 are the only elements found in both set A and set B. So, the intersection of set A and set B is the set containing the elements 2 and 4. Moving on to set subtraction, which we also call the difference of sets. The difference of set A and set B, denoted with either of these forms, is all the elements in the set on the left side of the operation, excluding any elements from the set on the right side of the operation. So the difference of set A and set B are all the elements of set A, excluding the elements from set B. The only elements of A that are in B is 2 and 4, which we found in the intersection. So the difference of set A and set B are all the elements of set A, dropping the elements 2 and 4. Similarly, the difference of set B and set A is all the elements of B, just dropping 2 and 4, since those were the elements in our intersection. Finally, let's talk about complements. The complement of set A is normally denoted with either of these two forms. The complement of set A is all the elements in the universal set U, dropping all the elements of set A. So pretty much the set U subtracting all the elements of A. Our universal set contains all the integers 1 through 10, so if we drop all the elements of set A, we are left with this. This is the complement of set A. In a similar fashion, we can find the complement of set B by dropping all the elements of set B from the universal set and getting this result. Those were the four set operations we are interested in exploring. Now, let's use Venn diagrams to illustrate these operations in a different way. When looking at the Venn diagram, you need to imagine everything in set A to be within this circle, everything in set B to be in this circle, and the outside area contains any of the elements of the universal set that are not in set A or set B. Using our sets from before, we could put numbers into this Venn diagram to match the sets that we did examples with. The intersection of set A and set B contain the elements 2 and 4, so we'd put 2 and 4 in this middle section where both circles overlap. This represents the intersection of our sets. Everything in set A excluding 2 and 4 would go over here in the remaining area within set A. Everything in set B excluding 2 and 4 would go here, the circle representing set B. Finally, everything from our universal set U that is not in set A or set B would go in this outside area. It is not uncommon for sets to kind of be arbitrary, where we don't know the elements of the sets when working with Venn diagrams. So for the remainder of this video, we are going to work with an arbitrary set A, set B, and set U. And we'll note that set A and set B are subsets of the universal set U. Our goal here is that if we're given a set operation containing set A, B, or U, can we shade in the portions of this Venn diagram that would contain the elements of the operation? Quickly, let's go through a few examples where we're going to shade in the part of this Venn diagram that matches the set operation given. Set A would contain all the elements found within this shaded circle. Set B would contain all the elements found within this shaded circle. The union of set A and set B would contain everything in both circles, which ultimately ends up being this entire area here. The intersection of set A and set B would contain the shared elements of set A and set B. In the diagram, the overlap of these two circles would represent the intersection of set A and set B. The difference of set A and set B would be all the elements in set A excluding the elements from set B. So we would drop the overlapping section and be left with this shaded area. The difference of set B and set A would be all the elements in set B excluding the elements from set A. We are left with this shaded area. The complement of set A would be everything in the universal set excluding everything in set A. So we would just drop everything from set A out of the universal set and are left with this part of the diagram. The complement of set B would be everything in the universal set, excluding everything in set B. We take everything in set B out of the universal set and are left with this part of the diagram. Now, all of these results represent different set operations, and will be the building blocks of any problems that involve more complex set operations between these three sets. Check out this playlist for more videos on sets. I'm Joe, and thanks for spending some time with me.